All right, so for the sine, like I just said, we're going to do the y, or the y coordinate, divided by the radius, which is basically the same thing as the opposite divided by the hypotenuse. Okay, and then we're going to think about the cosine as the ratio of the horizontal displacement of P from the y-axis and the distance between the origin and P. Now, if I was to draw this, I probably would have had this be X. So then you're still kind of like thinking SOHCAHTOA, that's the adjacent. I didn't make this, so it's fine. It's perfect the way it is. It's just not exactly what I would have done. But anyway, the horizontal displacement is going to be the X, and then that distance is still going to be the radius. All right, and then whenever we are talking about tangents, it is the ratio of the vertical displacement to the horizontal displacement. They also call it the slope, and it is actually. So the slope, if you guys remember, is the change in y over the change in x, which is the horizontal displacement over the vertical displacement. So that's kind of cool. So this is going to be y over x. And then throughout the year, we're going to talk about these trigonometry identities, and this is one of them. So if you didn't know y and x, but you did know what the sine of theta and the cosine of theta were, the sine is also, the tangent is also equal to, oh my goodness. The tangent is also equal to the sine of theta over the cosine of theta. All right, let's do some examples. So for example 1, the figure shows a circle centered at the origin with an angle of measure theta in standard position. Now, theta is just a Greek letter. So it's just a variable from the Greek alphabet. Like x is a variable from our alphabet. But most of the time, angles are represented by Greek letters. And so we're going to use theta a lot, but we're also going to use alpha and beta and gamma and omega. So it's okay. It's just going to be a different variable. All right, so the terminal ray of the angle intersects the circle at point P, and the coordinates of P are x, y. Which of the following is true about the cosine of theta? So you guys read through those choices. What do y'all think for cosine? A, yeah. So I didn't say this, but if you look at this circle, it tells you, because the circle goes through the point 3, 0, the radius is going to be 3. So everywhere on that circle, this is going to be 3. And then the horizontal displacement is x. So it should be A. All right, let's look at the next one. For example 2, the figure shows a circle with a radius of 5. So it tells you the radius is 5, and you can also see that the radius is 5 from that point. The terminal ray of the angle intersects at point P. We're going to find the following values. All right, so we don't know the ordered pair at point P, but this has the same vertical distance, different displacement, but vertical distance, and same horizontal distance. So what do you guys think the ordered pair is for P? It's going to be 3, negative 4. Just you go down instead of going up. All right. And that's our x and our y. Our r is 5. And so if we can remember the x, y, and r rules, to find the sine, we're just going to do the y over r. To do the cosine, we're going to do the x over r. And to do the tangent, we're going to do the y over the x. Okay, let's look at another example. Unless you guys have a question. Okay. This has a lot going on. And so we have this circle, the center is at the origin, the radius is r. And let's see, the angle theta is in standard position. So this is our angle we're talking about, that's theta. And then we have all these other ones that are formed by reflecting this angle over the y-axis, over the x-axis, and then over the origin. And so they all are going to have the same distances from the x and the y-axis. And so for point Q, what would you say that ordered pair is? If P is xy, what would Q be? Negative xy. What about R? Good. And then S should be x negative y. All right. Now, something I always try to get my students to understand is that the abbreviation of sine is sin, but you still say it's sine, you don't say sin. Cosine is still cosine. Tangent is still tangent, but it doesn't exist without an angle. So in a second, for example 4, we're going to find the sine of the angle whose terminal ray is S. So we would start at the positive x-axis and rotate all the way around. That purple angle is the angle we're about to find the sine of. And I'm going to call it alpha. Now, there's not a great place to label the alpha, especially if you don't have different colors. But alpha kind of looks like a fish. It kind of looks like an A, too. And so what we're going to do is find the sine of alpha. So the sine doesn't exist without an angle. So you can't just say sine equals. It always has to be the sine of some angle equals. All right, so I could go back up to my circle, or I could just look at my ordered pair. So all you need is that ordered pair. And so if I'm going to find the sine of alpha that is corresponding with point S, we're going to do the y over r. And that's it. Okay, and then for example 5, we're going to find the cosine of the terminal ray, or the angle whose terminal ray intersects with Q. Okay, so this is going to get kind of messy, but we're going to rotate from the positive x-axis to the terminal ray of Q, and we're going to call that beta. All right, and so we're going to find the cosine of beta. So we're talking about Q, so we're going to use this ordered pair. Cosine, we're going to use the x coordinate, and we're going to divide it by r to get the cosine. Right, and then for example 6, we're going to find the tangent of the angle whose terminal ray is at r. So we're going to draw one more angle. We're going to call that gamma. Gamma for me is a little more difficult to draw. It doesn't really look like that. I think it's a little less symmetric. All right, so we're going to find the tangent of gamma. And that's going to be the y coordinate divided by the x coordinate. So we have negative y divided by negative x. You wouldn't ever leave it like that because you know that a negative divided by a negative is a positive. Now the ones that are on your assignment have actual numbers for x and y, which to me makes a little bit more sense than just using x and y. That's okay. Okay, we are going to hold off on example 7 because I want you all to have some time and go to example 8. Okay, so we're going to let theta be the angle in standard position whose terminal ray intersects the point P and coincides with the line y equals negative 3/5 x in quadrant 2. The coordinates of P are negative for y. So we know the x coordinates. We don't know the y coordinate, and that's what we're going to find. We're going to find the y coordinate. Okay, so back at the beginning of the lesson, we talked about tangent being y over x, or the change in y over the change in x, and also being the slope of that ray. And so it tells us the slope, well, kind of. It tells you it's the line. What is the slope of this line? -3/5. So one thing we know is that the tangent of theta is equal to -3/5. What else is tangent equal to? Using our points. What would you do? You put yeah, y over -4, or y over x. Our x just happens to be -4 in this case. All right, so if both of those things are equal to tangent of theta, that means they're also equal to each other. So that's what we're going to do. We're going to set those two fractions equal to each other. And then to solve, we're just going to cross multiply. And we get our y coordinate. A lot of times on these problems, it is some kind of weird fraction, but that's okay. Just leave it a weird fraction. And then just double check that you have the right sign. So P, if P is in quadrant 2, the x is going to be negative, and then the y is going to be positive. So you're probably good. All right, so what questions do you guys have?